So thanks for coming. Sorry for this. My name is Matteo, and today I'm going to speak about OpenComponents, which is a framework that we developed at OpenTable for developing and deploying HTML components. I'm going to speak about what I mean with HTML components a little bit later, and first I want to tell you who am I. So I write software. I've been doing it for a while. I'm based in London, and I work for OpenTable, which is a company based in San Francisco, but we are worldwide in North and South America, Europe, and Asia. The core of our business is we do free restaurant reservation, instantly confirmed, based on the fact that we have more than 32,000 restaurants worldwide that use our software on their restaurants to handle tables, payments, and other stuff. We have consumer websites, mobile applications for any kind of platform that drive users to make more than 16 million reservations every month. And we have something like 500,000 reviews per month. This is nice, I think, to understand a little bit the scale we are speaking about. And all the story starts with the usual monolith. So everything starts a couple of years ago. We had a big application and the same code base for pretty much consumer websites, mobile application APIs. We had partners APIs to do integration with partners, admin tools. Everything was in a single code base and application. Obviously, it wasn't ideal because we were deploying every month. We switched to 2 weeks, but I've seen worse, but it's not the best thing in the world. We were not very resilient because we were not able to push a lot of changes every day, and a big, huge code base was not very easy to test and to approach to. I'm speaking about a company that has been around for something like 15 years. So we had more than 10 years of contributors for hundreds of engineers. And not very robust, because obviously deploying every 2 weeks, we had to deal with when we had something wrong with a deployment, postponing our features, coordinating our releases. And when we had some problems, everything was propagating in an uncontrolled way in different parts of our business. So that was not very good. Still, we had some advantages. So everything was written in a single language, and that was good because we were very good on writing C# in our situation. And we had very dedicated team for infrastructure, so they were very experienced on deploying applications on Windows, how to debug them, and also we had dedicated teams for testing that were very expert about how to test applications in Windows. So a couple of years later, we decided to break everything into very small microservices. So all of our backend, obviously, we decided to break it in very small services. And the result is that our code evolved, but as a consequence, also culturally, we changed a lot. Once we started working in this way, we started working with very small and focused teams. Teams for 3 to 5 people were owning very specific parts of functionality, very specific functionalities, very small code bases, and they were able also to release and to deploy easily. Also to test applications better and to work with product a little bit closer, so they were able to release and to bring more value to the company in a more efficient way. Given that this took a couple of years, because we tried to do it, we made a lot of mistakes, we made it better, we learned a lot of lessons. At the end, we saw a lot of pros because we became good on adding consistency, how to do that, and we decided to bring the same approach to the front end. So the front end was still a big legacy website written in a single language. And we wanted to be like the backend. We wanted very small teams to be focused on very specific parts of our website, but we wanted to somehow have the possibility of bringing more happiness. So teams needed to work to still be coordinated because we were working on a big website, but we wanted to break it on smaller parts. So what we started to do is working on what we call microsites, which is something that people associate to many different things. In our situation, what we call as microsites is very little applications, one web page or maybe a couple, and the idea is that having a front door service, every little application is a little bit more encapsulated. The idea is that when a user goes to a website, which is a big website that perhaps is deployed in many parts of the world in many languages, you shouldn't notice that that's actually split in very little microsites. You should see a website that looks like the same website, but actually behind the scenes, we wanted to have everything split in smaller pieces because we wanted to deploy daily, we wanted to test better our applications, we wanted to be more agile. How to do that? We started working on that just for a couple of features. We started rebuilding the search results microsites in our website. Then we started working on the restaurant profile, and that worked very well. It wasn't very easy, as again, we had to learn how to do it very well. But immediately we saw a lot of advantages. The idea was be more agile, and we achieved that. We had quick deployments. Teams were deploying daily instead of waiting 2 weeks. We had more focused and effective testing, because testing a little web page is absolutely easier than testing an entire website, even if we still needed to test more complex, obviously, end-to-end interactions. We were more robust. When a microsite was down, everything on the website was up. And having small teams that have ownership of that little piece of code and functionality makes this possible. Also, we were able to first approach to new technology stacks. So having little microsites independently deployable made us possible to start writing more node.js, to write other stuff in other languages, or maybe to keep writing C# but with mono, etc., etc. So the first problem we had to achieve was one of the most interesting, is the common parts. So obviously when you do something like that, what you need to solve is you need to offer the same experience to the user in terms of performance, but we want separation underneath, how to achieve that. So what we found out when people started doing this was that everything was going not very well. People were duplicating a lot of static resources, for example, for the website, because they wanted to be up when everybody was down in case. So they wanted to be very robust. They wanted to not depend on anybody. Everybody was duplicating markup, JavaScript. That wasn't very good, because that was affecting performance for the end user. Also, a lot of inconsistencies. When we had started to build Microsoft, and we wanted to change a little link on the footer of the website, instead of making a change in a single place, now we had to do a change in 5, 6 places, and we had to ask 5 or 6 teams to do a change and to be coordinated. We had to deal with inconsistencies. Plus performance. As I mentioned, everybody wanted to use their JavaScript, their CSS. They were duplicating everything. That was terrible for the end user. So to solve this, we built a little MVP in support of this approach, was to build a REST service, a REST API that were able to serve the UI elements. So the idea was to have a little REST interface that were able to serve HTML as an output, so something like an API for HTML snippets. So everybody were able to put a rendered HTML result in a Node.js application or a Python application, because HTML wasn't in need to be rendered anymore. Also, we used headers for example, accept language to have different kind of language-specific variants, or cache headers to improve performances. And then we wanted to also handle server-side logic. So one cool thing was, I want the header here, and I am this microsite, just put it here. And if the header needed extra resources, needed to go to data sources to consume other services, we wanted to delegate this to the service. So we wanted a little API that could just give the snippets to the microsites, and that was it. Also, obviously, ability to host the static resources. So if the logo was referenced in this little snippet and everybody was putting exactly that markup in multiple places, the original problem was solved. So everybody was, at the end of the day, as a end user, looking at the page with exactly the same markups for the common elements. So, and obviously we built it also for the JavaScript and the CSS. So a big CSS bundle for all the layout, a big JavaScript for the big libraries, and also the performance problem was solved. So at the end of this experiment, we found out the microsites were kind of working with this approach. Obviously, there are other ways to solve problems like that. So there is client-side rendering, for example. So you can do IX requests for each shard components you want. But obviously, if you need for SEO purposes the content to be rendered on the server side, this is not doable. For example, for the footer or for the header, you need that content rendered on the server side. Iframes, pretty much the same. Server-side includes are something that, for example, Nginx offers. So you can do, and other third-party CDNs. There are a lot of different kinds of technologies in form of proxies or composition layers. This is doable. The only problem is that we tried a couple of things and we found out that everything was trying to do some magic to solve our problem. What we wanted to do instead with our API was to make the contract very clear. I want the header with these parameters for this language. And microsites and the idea of having everything on the macro world was they wanted to exactly know what was happening. They didn't like magic. Asset compilation during build time is another option. Obviously, you can do it for some specific, for solving some specific situation. In our case, it wasn't an option, unfortunately, because we had teams working on the same website, but working on different microsites located in San Francisco and London and India. And when we had to coordinate a release, and when we had to put a change everywhere, we couldn't ask everybody to deploy on the same time. We wanted actually to empower people to deploy when they wanted. So, did it work? It worked a little bit. We had consistency, so now everybody were able to, we had a specific team that were working on the common components. So we started calling components, and we were able to see a consistent result all across the website. We solved the coordination problem because everything was handled by a team that was deploying the common web components, and everybody couldn't just care because they just had a single contract that was, I want the header, the footer here, and I don't care about what is there. The front-end problem was solved, so everybody was navigating now as every end user, seeing the same resources, so performance problem was solved. And also, it came out that we wanted to use the microsite as an approach to rebuild a big legacy website. So this actually solved the fact that it was very easy to spin up new microsites, so to facilitate this migration, because we were able to progressively build part of the websites and to plug them and replace the old functionality in weeks. Obviously, the problem is that now we add a new hard dependency for all the front end. So if this service was down or slow, everything was down or slow. And we had to work a lot to make it stable and to make it super quick. So I'm speaking about, for normal days, something like some millions of requests sometimes per hour, and having always the response time under, with a mean under 5 milliseconds. And obviously something that came up is a lot of people got enthusiastic about that. They wanted to create components for that, but it wasn't very easy to add new components. So so the new service, we didn't want it to become a new monolith. So that's why we built OpenComponents. OpenComponents is a little framework that comes from the experience we got from the previous situations in support of this, but also in support of new functionalities. The way it works is that it's very similar to the NPM registry. So we have an OC registry, an Open Components registry, which is an REST API. And then we have a CLI that empowers people to create components and to publish them to the registry. So what happens is the registry is used also for microsite or for websites in general to consume components. So to get components both on the server side or on the client side. And the registry behind actually has a piece of infrastructure that takes care when a new component is published to automatically decompose this component, do a lot of transformations such as minification of assets, etc., deploy everything to S3 and to CDNs and distribute this component worldwide. Then there are something we call OC runtimes that automatically, for each request to the registry from component consumers, like microsites, take care of executing the server-side part of each component. So the idea of open components is every open component is like a very tiny MVC application that runs via a REST API, and that is exposed to the world via a REST interface. And the framework is itself a way to spin up a new component and to deploy it. So in this way, we have people that can create or reiterate to existing components. Every time they are ready to publish it, in a matter of seconds, they can release this component worldwide, and automatically the component is distributed. So I'd like to do a demo now, but I may miserably fail, so I'm gonna just try. And if I miserably fail, I'm gonna go back to my slides. So the idea is I want to create a new folder. So for example, can you see my screen or should I zoom? Yes, it's fine. So I want to create like a LNUG component. And then, let's do a dir for like test LNUG. And I want to enter this folder. Then I can create OC is open source, so you can npm install it globally. I can do OC init LNUG component, and we support Jade and handlebars, and the component is automatically created. Now, as soon as I do this, I have a component. It is very simple. I don't remember where I am. Test LNUG. Yes. So a component is pretty much a template. In this case, it's a Jade file. I have a server.js, which is pretty much a method that exposes a callback and decorates a context object that is a request that contains requests and stuff for making static resources compilation. And then is a package JSON that describes the working and can be set with a lot of optional parameters. The idea is that that's the only thing you need to create a new component. So when I want to create a new component, I can do something like div my LNUG component, and I can write this to my I think the component is called LNUG component, yes. Yes. And then I want to see how this thing looks. So I have something that is called dev watcher. So it's like a test registry that can run locally in a port. And this automatically looks for changes here. Now I can do something like a C preview, HTTP, localhost 3030, LNUG component. And I can see this thing here. So the thing I can do here now is I can change this, and I can do stuff like add parameters. For example, in the Jade world, I can say something like hello, and I can save this. And here I can do something like hello, is something like context params dot hello, or I can save this, and here I can say something like that. It automatically works. So the day watcher automatically starts that, and obviously I can pass parameters. So if here I add something like params hello, I can do stuff here like hello equals hello, and automatically here I can see the parameter. So the idea is this is a very little MVC application that is very useful because this takes care also. I can reference images inside here. I can use CSS and static files, and this is automatically bundled and it is automatically deployed to production. So this is very useful when you want to do like A/B tests, because A/B tests are pretty much like a piece of JavaScript that wants to handle the DOM and wants to do transformations. You can create a component for that, and you can just release it. Another thing that is very cool is that at some point I want to stop developing this because I feel like I'm happy. And I can do something like a C, registry, add, and here I have created one, which is LNUG demo. To app.com, and if this is a valid registry, it should work, and if connection works, which seems like challenging, but finger crossed, and yes, and then I can do something like a C publish the component, and that's now published. So in 1 millisecond I deploy to production, and this is now online. So I can go here in my browser, and I can see that this component is here. So obviously we have the rendered result, we have versioning. So as the same thing we have with NPM, we can actually use it to hack versions. So every component, every time I publish, is semantically versioned and immutable. So I never am able to override a component. I can consume just the latest patch or version of a component. This is very useful for doing A/B tests. And also, I can obviously pass parameters to components. And I'm gonna finish with my slides now, because maybe I'm very late. So this is how we create a component. This is how we deploy it. And then, obviously, we can handle static resources as well. As soon as I run the dev watcher, I can put images and static files in my component. As soon as I deploy it, that's transformed in order to work with my CDN. So client-side rendering is easy as that. So the idea is we have a little JavaScript client, which is a couple of kilobytes big and supports IE8 and stuff like that. This was needed for our business. And the only thing we need to do is actually to put an OC component with a href tag. You can optionally specify the version of the component and the parameters, and this component is there client-side rendered as soon as the DOM is ready. If you use node.js, you can do server-side rendering, and obviously this is very intelligent because you get the component not rendered yet, so you get behind the scenes, the request gets the component uncompiled, so a compiled view and all the view model you need, and the compilation happens on the node.js optionally. And this is very useful for performances because we are able to nest and to create a complex application with dozens of components that render in very, very quick. And obviously, with Node.js is very easy because we have a simple library for that, and you can just put your component, and it plugs with any kind of framework because it is not, this is what we needed for our business. And the cool thing is that if you are not in the Node.js world and you want to put a component in a C# application, for example, you can use a specific REST code, a specific endpoint, and you can get the rendered result as well. So you can just take the HTML and plug it inside your page on the server, on the client, and you can do it in a non-Node.js world. This is pretty much what you get in case you want actually to render yourself on the server side. For example, we did a little prototype of a C# application rendering JavaScript because that is possible. C# executes very well JavaScript. And if you want to do it, you can get the compiled view plus the view model, and you can do this. This is all done with a library that we released, and it's all open sourced. So the goal we wanted to achieve with OpenComponents compared to the previous approach was we wanted to enable people to create components independently and publish them. So that was very important for us, for our business, because we have people distributed across different continents. And when we wanted to release something on a UK time, we didn't want to wait for a San Francisco team to release that. So in this way, we were very well decoupled. Teams were empowered to move on independently. So components, we basically transformed components and as data. So this allowed us to release these components to this infrastructure without any other deployment, and also allowed consumers to have more granular control. So they could include the header for a specific version or for a specific patch or for a specific minor, because all components are now semantically versioned. So if someone breaks something, it's very easy for a consumer, for a microsite to say, I'm going to roll back and I'm going to get the old header or just the latest or the latest patch, etc. And also, client-side rendering is supported as well, and is very optimized. So the library that is very tiny, is a couple of kilobytes, actually takes care of doing a lot of magic, such as requesting the component and doing the rendering itself, but also allows nesting and allows re-rendering in a very, very quick way. And this is a little bit surprising, but as soon as we realized this, we found out that teams loved it for A/B testing. So creating components and publish them in production allowed people, making it so easy, allowed people to create tests more quickly. So that actually served as a new neat way to have our A/B tests actually in GitHub versioned, because they were now components and they were very well testable, because components, I'm not speaking about that, but components are very nicely testable on the unit perspective, but also on a acceptance and end-to-end perspective. And that was important for us. So I think that's pretty much it. Conclusions is SOA is not just about code. So what we realized is we wanted to approach better to backend, and our code evolved. And then, as a consequence, we found out that the way we were working on code evolved. So teams changed, we changed team structures, and people and the culture changed. When we started working on microsite, we found out that actually code evolved again as a consequence of the culture change. So the idea is SOA is probably 50% about code, 50% about culture. You need to readjust your code, but also that has consequences on the way you work and the way engineers interact with them, with people. So when dealing with dependencies, we need love. The idea is when we started working on the first prototype of creating an API and including a new R dependency for all the front end, we thought that it was a little bit crazy, because we were including a new dependency. And in the SOA world, one thing, and in the microservices world, given they are two different things, you want to reduce dependencies as much as you can. But the idea is that when you put some love and you make these dependencies work, perhaps it is not a bad thing. And that's it. OpenComponent is open source. If you want to try it and let us know. And thank you. Any questions? Yes.
Yeah. So, is there an open registry that anyone can publish?
Not yet. So the registry itself is easy to spin up. What you need is an S3 account at the moment, and you can use the library to spin up basically a configuration and to spin up yours. We may really, I never thought about actually creating an the one that I shared on the presentation is actually free if anybody happened to do the same thing I was doing. Probably not, because it's late and people is tired now. But the idea is that is totally possible, given that someone wants to pay for an S3 account. But yes, that will be possible. Other questions? Yes?
There's a similar functionality introduced by Origami that's done by Frontend. We looked into that for simultaneously.
Yeah. So the question is if there is a solution by Financial Times called Origami, if I recall, and the question is if we had a look. So We had a look at all the frameworks that were around. For example, one of the most interesting stuff for us were the Google Web Components in general. The problem is that they were not ready yet for us in order to be performant and usable. And we are still looking forward to that. Other stuff like Financial Times, I don't know if I heard about origami, but I remember a project called Fruity something from Financial Times that were very interesting, and there are a lot of common ideas. The problem is that what we had to do was a little bit different. So if I recall, that project had a very similar approach for the isomorphic rendering of very little encapsulated components. The only problem was that making it work in an application needed kind of a build step. In our case, we wanted to do something on a runtime, so something like the API for us was required. Obviously, I'm not saying that this is the best approach for everything. It was a very good approach for us and for the specific situation we had. And again, I feel like the future for me is more like the web components, is that definitely the Shadow DOM and the includes and these functionalities are something that really inspired us to build this, but we needed something a little bit different. For example, able to support all IE versions, we do because we need it for our business. And this is in production now, and it's been there for a couple of months. It handles traffic very well, and it works very well for us. I don't know if it would, but for other people, perhaps for other people, I would imagine to be a very powerful system for doing A/B testing. That's like something we are exploring, and it may be very, very interesting. I don't know if I answered. Question? Oh, yes.
Hi. Very nice idea. Assuming that you have like two teams working different component and like a glitch is happening, how do you debug the glitch? Because assume that the glitch will happen because of the integration of two components.
So, okay. So the question is, what happens when two teams work on the same component?
Well, well, because there's integration between components, and there's not a integration stage environment because you are publishing the components. How like a developer can work with another team to fix the integration glitch or something?
This is actually a very good question. So one of the biggest problems we had with the first approach, so the first API that were serving the components on the rendered way, was that that was like a little MVP for testing this approach, but we didn't add a very good control about what was going online. So the problem was someone was deploying the new header and he was putting a piece of JavaScript that perhaps were totally fine for a microsite like the home page, but were introducing troubles for another page like the search results. So that was a problem. And in order to do that, we had to put in place all the infrastructure to do a lot of testing. So something that probably I forgot to mention is that both the first approach and this heavily rely on testing. So for us, it's very important. So we have a continuous integration pipeline, and in order to guarantee that things don't break, we heavily rely on testing on the single microsites, and also all the integration testing every time we release something. On the other hand, on the first time we did the first experiment, we didn't have very much control. We introduced something new on the OpenComponents. So the idea is now that every component is totally immutable every time you deploy it, and it has a semantic version. Implies that if you use properly semantic versioning when you release components, you actually have as a microsite, as a consequence, a lot of more control. So as a microsite, you can say, I want the latest version of the header, or maybe I want just the latest patch of version 1, or maybe the later minor version. So the idea is, if obviously there is trust and obviously people use semantic versioning properly, if they create a new breaking change for the header, they should put a new version for that. And if you consume the latest patch, you shouldn't get it. So that's how we think like interaction should be improved in this new version, because still we rely on testing a lot, but as a microsite you can just consume the latest version of something, but in case something is bad or something, or you don't trust a team, which can happen, you can just say, I want to consume exactly that version, and I will manually rebuild my application every time they release something, because I want to do my testing offline before putting that on my continuous integration pipeline. So it is complex. I may speak about testing for a couple of hours. Hopefully I answered, yes.
We've got a call time.
Okay, so I'm gonna ask, I'm gonna be here, so forward me other questions later, and I'll be happy to speak about that. So thank you.